Welcome to myprojectbazaar.com.
Next, we discuss about the product for design and testability support for launch and capture power reduction in launch of shift and launch of capture. Next, we will see the abstract for the product. At speed and even faster than at speed, testing of VLSI circuit aims a high quality screening of the circuit by targeting the performance related faults. On the can, the compact test set with high effective patterns, each detecting multiple delay faults desired for low cost. On the other hand, such pattern increase the switching activity during the launch and capture operation. Pattern optimize quality, cost many, thus end up violating peak power constraints, resulting yield loss, while the pattern generation under the low switching activity constraints may lead to loss in test quality and or pattern count inflection. In this paper, we propose a design for testability support for enabling the use of set of pattern optimized cost and quality as is it in a low power manner. We developed the cost and quality not at yet in a developed manner. One of the launch and shift and one of the launch and capture and another one of the mixed testing to be followed. The proposed DFT support enables the designing of partition approach where any set of pattern generated from the power unwired manner can be utilized the design of region at a time, reducing both the launch and capture power in a design flow compatible manner. This way the test pattern count and the quality of the pattern optimized preserved with while lowering the launch and capture power reduction. Next, we will see the flow diagram for the product. First, the input test patterns. The input test patterns are applied to the S9234 benchmark circuit. The S9234 benchmark circuits, it's a standard architecture. It's a one type of combinational architecture. The combinational architecture mainly based on the NAND gate function. This architecture results are input test patterns. The input test patterns applied to the load state block. The load state block to be controlled by the restore function. The restore function to be activated the scan enable functions. The scan enable function to create the restore operation, then the restore operation to perform the launch and capture block. The launch and capture block is mainly used to the capture the test pattern and to apply the launch of shift processing elements. The LOC block is mainly based on the number of input test patterns. Thus, the 11 test patterns to be applied for the process. The 11 LOC block is to be processing by the our testing architecture. Thus, the architecture to pass the interface register. Interface register is one of the without clock register element. It's a latching process to be applied. Thus, the input to be just storage the interface register and to pass the shadow. The shadow register is finally considered by the final test pattern results. The final test pattern results to store the shadow register and to apply the launch and shift operation. This launch and shift operation to be activated by the scan input signal. The scan input signal to be set, the launch and shift operation to be processed. The launch and shift operation at the same time the shadow register to be applied the last bit and to compare the XOR gate function, then the expected input to be processed and the scan input to be applied, thus the two input to be considered, and finally we calculate the fault detection process and the output to be calculated by the synthesis and simulation results processing. And finally we discuss about the output for the product. Just open the Xilinx ISC project. Our design and testing product is developed by the VHDL language, and we follow the structural modeling for developing the our design and testability architecture. Next we select the simulation, and to double click the simulate behavioral model process, just we simulate the our LOC architecture. Then the process is simulate behavioral model is completed successfully, and to create the ISM simulator graph, just we apply the processing results. The scan input to be applied for the process, just the scan input. Clock initially to apply the 0 processor, then the scan enabling process to be activated. The benchmark circuit input is to apply the any of the input. We just run for the time specified on the toolbar. Next we apply the clock 1 results. Then to activate the scan input signal and deactivate the scan enable signal. Play the clock fully. Then we output the output test pattern results, and finally fault detecting signal to be 0 for the simulation result. We just certify the testing architecture simulation result. Then to calculate the implementation process, then create the view RTL schematic, add and create schematic. This our the LOC and LOS based testing architecture. Just we develop the benchmark circuit and the overall combinations for the RTL diagram. The RTL diagram which represents the what are the logical blocks placed in our testing architecture. Then we go to the technological diagram. The technology diagram to represent the what are the lookup table and flip-flop pairs, then input output connections are placed by the in our testing architecture. Then go to the design summary process. The design summary process, we select the synthesis report. The synthesis report mainly used to the area and timing calculation. This is our the area for the testing architecture. Then we calculate the time for the path delay 1.167 nanoseconds for our the testing architecture results.